Okay, good morning to all of you. I welcomes to all in our lecture series on probability and statistics belongs to 5th semester mathematics honors. In this class we are going to discuss Chebyshev inequality or theorem. So this is the statement of this inequality or theorem that if x is the random variable with mean is mu and variance is sigma square, then for any positive number k, small k, okay, we have probability of x minus mu mod greater than equal to k into sigma will be less than equal to 1 by k square, or probability of x minus mu less than k into sigma greater than equal to 1 minus 1 by k square. So this is the two ranges where mu is your mean, sigma is the standard deviation, that is your root over of variance, and we know that variance is your sigma square. Okay, and here k is positive real value. So this is the statement of this inequality or theorem that we are going to prove in detail, because this theorem always more oftenly most of the time you can found in your exam. Okay, and here I am going to say to you that uh, before you have to start your writing your note from here, you just write down these two lines. Chebyshev's inequality or theorem used about the range of standard deviations around the mean in statistics. And second point is that this theorem can be applied to any probability distribution that may be discrete or continuous, in which mean and variance are well defined or known. So if we know the mean of the discrete or continuous random variable, suppose this is the mean and this is our real axis, x axis, and this is our mean, and suppose this point your mu plus k sigma and this point will be mu minus k sigma, that means this is the distance is your k sigma, then we can found the probability in this range or beyond this range and beyond this range. Okay, here I can show you one example belongs to normal distribution, already we have been discussed in our previous classes. This is your mean value or mean point, and in between this 2 point whereas the standard deviation is plus sigma and minus sigma, in between this the probability will be 68.26 percentage. Likewise, for discrete probability distribution also we can use this inequality uh, to find any range of probability. Okay, and this inequality and or theorem also useful to determine the probability for a unknown probability distribution. As we know that probability, suppose probability of x less than 3, that means probability of x equal to 1 plus probability of x equal to 2, 2, that means suppose the random variable is belongs to 1 2 3 4 5, and probability for x less than 3, that means we have to consider probability x equal to 1 and probability x equal to 2 for the discrete, and for the continuous it will be fx dx 1 to 2, we can say. That means to find the probability of a random variable we need PMF or PDF. But if we do not have PMF for discrete and PDF for continuous, then also we can found the probability by using this inequality or theorem. This is one of the problem that the random variable x has mean is your 8 and variance is your 9, and an unknown probability distribution. And an unknown probability distribution, find the probability of in between -4 to 20 and find the probability x minus 8 mod greater than 6. So for unknown probability distribution, we can estimate the probabilities by using this Chebyshev inequality or theorem. In this video, we are going to be prove this theorem. As we know, this theorem many times asked in our exam. Okay, so let's start. In this lecture, we are going to be prove this theorem, and in our next lecture, we are going to be solve this problem. Okay, so as I told that before, you have to start your note. From this you have to just write down these two statements. Okay, so before we have to start this proof of this inequality, first we have to define the range, that x minus mu mod greater than k sigma, what will be the range? X minus mu mod less than k sigma, what will be the range? Okay, then we are going to go for the detailed derivation or detailed proof of this theorem, because the range is most important here for this theorem. Okay, so here I written explanation of range. First we have to find out the range of x minus mu mod greater than k sigma. Here k is the positive integer, positive real number, and sigma is your standard deviation. Okay, so I suggest to all of you that this explanation, whatever I'm going to be explain now, the range of explanation of the range of this one and this one, you can write somewhere your note. And for the theorem, for the derivation of the theorem, these things not required to be write for the exam purposes. Okay, only this figure is required, right? So here you can see that we have to find out the range x minus mu greater than that of the k sigma. So here, whenever we are going to found this type of equation, you just consider that this is one type of equation of a circle. Okay, for easy understanding and remembrance, you just remember that if it is written that x minus mu uh, less than, here it is given that greater than k sigma, right? Greater than k sigma. So for this type of equation, suppose it has been given that x minus a mod equal to 5. Suppose it is given that x minus a equal to 5. You just consider this is a circle, equation of circle. That means if I am going to draw x and y axis, then center of the circle is at a. Suppose this is your a. Okay, and the radius is your 5. Suppose radius is your 5 and you draw the circle. So this equation means you just consider this one is your equation of circle whose center is at a and radius is 5. Okay, similarly for this case, x minus mu greater than equal to k sigma, we have to consider that mu is the center of the circle and k sigma is the radius, whatever I have been drawn here. This is the mu, this is the center is your mu, and let this radius is your k sigma, and I drawn a circle. Okay, now we have to find out what will be the range x minus mu greater than equal to k sigma, what will be the range? Okay, the range of the x will be always x less than equal to mu minus k sigma, and x always greater than that of the x plus k sigma. That means after this point all the values of x and beyond this point towards negative x-axis, all these points will be considered. How it is? See, this is the point mu and k sigma is the radius. This is the radius. So if we are going to be move along the positive x-axis direction, this point will be plus k sigma, or we can say this point, this this value is your radius is your k sigma. So this point will be mu plus k sigma, right? If I'll be move mu plus k sigma distance, then I will be reach over here. So this point is belongs to mu plus k sigma. If I'll be move backward of k sigma distance, then I will be reach at mu minus k sigma point. So this point is belongs to mu minus k sigma, and this point is belongs to mu plus k sigma, and this radius is your k sigma, this radius also k sigma. Okay, now we are going to be find out the value of x in such a way that x minus mu, that means from x to mu, if I'll be subtract from point x to mu and we are going to take the mod, it will be always greater than equal to k sigma. How it will be possible? You just check it. If I will take the value of x here x minus mu will be this much distance, right? If I will take the mod of x minus mu, obviously this distance will be greater than that of k sigma. So if I will take x here, or beyond this point, all the x values we can consider for x minus mu mod greater than that of the k sigma, right? Likewise, you can consider any point beyond this side. Suppose you can consider this one. This one is the point belongs to x. So x minus mu mod belongs to this distance, this much distance. Obviously greater than that of this distance. So x minus mu greater than that of or greater than equal to k sigma. That means all the values of x beyond this point will be acceptable to satisfy this condition. So hence, for this condition, what will the x value? The x values will be beyond this point and beyond this point. That means this point is belongs to mu plus k sigma. So x value will be always greater than that of the mu plus k sigma. And as this is your negative x-axis direction and this point is your mu minus k sigma, so we have to consider x values less than this value. X value less than equal to mu minus k sigma. Mu minus k sigma. If I will be consider all the x values less than this point, then this condition is going to be satisfied. If I will consider x values beyond this point, also this condition is going to be satisfied. So hence my range of this one x minus mu greater than k sigma is beyond this point, all the x values beyond this point towards negative x-axis, all the x values. So hence the range of this one is your this side and this side, from this point towards minus infinity, from this point towards plus infinity. That is your x less than equal to mu minus k sigma and x greater than equal to mu plus k sigma. Okay. Here another thing can be noticed, that if we are going to subtract this from this x value to mu, or from this value to mu, and if I am going to take the square, that means x minus mu square, or from this x minus mu square, whatever may be, it will be square value. I am going to telling about the square will be always greater than that of the k square sigma square, or you can say that x minus mu mod always greater than that of the k sigma. So hence x minus mu square always be greater than that of the k square and sigma square. So this range and this value will be required in our derivation. Now we are going to go for the another range, that is your x minus mu less than that of the k sigma. So this range will be in between these 2 points. How it is? See, here I am explaining that you just remember for your future that if whenever you are going to be found this type of equation or to find out the range, then this method will be easy for you. Okay, so here you can see that this is our mean value, that is your mu, and this distance this side up to this much is your k sigma, and this distance is your k sigma, which is belongs to or which is called as so called your radius of this circle, right? And this point is your mu plus k sigma. Mu minus k sigma belongs to this point. So we are searching that we have to consider a x value on this axis, that x minus mu mod always will less than the radius. So radius is this much. I am going to search a value of x which subtract from this x, mu is going to be subtracted and it will be always less than that of the k sigma or less than that of the this distance. You see, if I am going to take a point here, then from this to this, if I will be consider the distance from this to this greater than that of the this radius, whatever already we have been discussed here. So likewise, if I am going to consider here one point, so from this point to this point always greater than that of the this distance. So where I am going to take the x value, that x minus mu mod less than that of the k sigma. See, if I am going to consider here is your x value, x point is here. So x minus mu mod is nothing but this much distance. Okay, this much distance only, which will be less than that of the k sigma. Likewise, if you are going to consider this is the point belongs to x, negative x-axis direction, this is the point belongs to x, so this much distance is less than that of the k sigma, because k sigma is the this much distance, okay, the radius. So hence the x value we have to choose for this case to satisfy this condition. The values should be in between this point and this point. That means x will be always greater than that of this point, as it is negative x-axis side. So from this point towards this point we have to consider the x point. This point can be considered as x. So x will be always greater than that of the mu minus k sigma. So x will be mu minus k sigma, and this side x always less than that of the mu plus k sigma. X less than that of the mu plus k sigma. If I will consider this range, then it will satisfy this one, x minus mu less than that of k sigma. Okay, so this is the range whatever I am going to consider for this one. Okay, so collectively whatever I explained here I have been represented. You can see that this is your mu, this is your mu point, and this distance is your k sigma. This point is belongs to mu plus k sigma, this point is belongs to mu minus k sigma. This range, in between this range, is represented as mu x minus mu less than k sigma, and beyond this point, beyond this point, this range is represented as x minus mu mod greater than equal to k sigma. Okay, now we are going to go for the derivation of the theorem. Okay, so I suggest again carefully you have to watch and write down the note. So to prove these two, consider x is a continuous random variable. You can consider x as a discrete random variable, but if you have to follow the same procedure by considering discrete, also you are going to get the answer. But here we considered x is a continuous random variable. We know that variance of x equal to sigma square is equal to expectation of x minus expectation of x whole square. Okay, so expectation of x also can be written as mu, that is a mean. Expectation of x or mean of x, that can be written as mu. Whatever written in our statement, mu is the mean or expectation of x. So sigma square or variance equal to expectation of x minus expectation of x whole square. Here is the curly bracket, here is the curly bracket, square, whole square. That implies sigma square equal to expectation of x minus, instead of expectation of x, I can write mu whole square. Okay, that implies sigma square equal to x minus mu square into fx dx. Here fx is the probability density function of the random variable x. Okay, as it is a one dimensional random variable, so this is the probability density function. If we have to consider bivariate random variables of x and y, we have the bivariate random variable, then expectation of x will be integration of x marginal density function of x. Okay, where marginal density function, here integration from all the values of x. Okay, and here marginal, this is a marginal density function of x for bivariate random variable, and this is nothing but integration of probability density function into dy, that we know. But as it is a single random variable, so this will be pdf, probability density function of x. And we know that expectation of x is nothing but x into density function, and expectation of x square is nothing but x square into dx for bivariate random variable. For one dimensional random variable, expectation of x square will be x square into pdf of x dx. So here x square is there, so x square into pdf into dx. Here x minus mu square is there, so x minus mu square into pdf dx minus infinity to plus infinity. And this whole range can be written like this, that minus infinity to mu minus k sigma up to this point, one integration x minus mu square into fx dx plus mu minus k sigma to p mu plus k sigma x minus mu square into fx dx plus mu plus k sigma to plus infinity x minus mu square into fx dx. Okay, here as we know that mu is the mean, sigma is your standard deviation, k is any positive real integer. Okay, in the above equation, in this equation you can see that mu is positive. Okay, and k is positive, and sigma also will be positive because this is the variance, means also positive. And here you can see this is the x minus mu square. X minus mu square means this is a positive function, so this whole term is a positive function. In the above equation, this one, in the above equation, the term, this one, mu minus k sigma to mu plus k sigma fx dx is a positive function, right? If this is a positive function, and I am going to remove this one, then we can found this plus this, but sigma square equal to this term plus this term plus this term. Okay, so if I am going to remove this positive term, obviously sigma square will be greater than that of the these addition of these two terms. Okay, see, sigma square equal to addition of these three terms. If I am going to consider these two terms only, addition of these two terms, obviously sigma square will be greater than that of the addition of these two terms, because I subtracted one positive term. Therefore sigma square will be greater than equal to minus sigma minus infinity to mu minus k sigma x minus mu square into fx dx plus mu plus k sigma to infinity, mu plus k sigma to infinity x minus mu square into fx dx. Let this is your equation number 1. Same thing I have been written in this page, that this one, this is our equation number 1, this is your minus. Okay, minus infinity to this one, mu minus k sigma, and this let this is your equation number 1. Now we have to consider the x minus mu mod, which is greater than that of the k sigma, whatever given in our statement, that we have to prove this one. So now we are going to consider this range x minus mu greater than that of greater than equal to k sigma. So as we discussed here, that x minus mu greater than equal to k sigma is nothing but x less than mu minus k sigma, and x value should be taken as greater than equal to mu plus k sigma. That means for this, to satisfy this condition, we have to consider the x values beyond this point, beyond this point. That means x less than this point, less than equal to mu minus k sigma, and x values should be greater than that of this point, that is your x plus k sigma, right? Therefore if it is so, so obviously x minus mu square, already we have been discussed here, x minus mu square always greater than that of the greater than equal to k square and into sigma square. X minus mu whole square will be greater than equal to k square into sigma square. Let this is your equation number 2. Because as we saw that either I have to take this side x minus mu is this distance. If I will take this side one point as x minus mu is this much distance. If I will consider the whole square of this distance, obviously that will be greater than that of the radius square of this radius, that means k square sigma square. So x minus mu square greater than equal to k square sigma square. Now use this equation number 2 in equation number 1. What we can found? So instead of x minus mu square, I can write k square mu square. Here x minus mu square is greater than that of the k square mu square, right? So instead of if I'm going to write k square mu square over here, so obviously sigma square will be greater than equal to minus infinity to mu minus k sigma into k square sigma square into fx dx plus, this is the range, mu plus k sigma to infinity k square sigma square into fx dx. Okay, that implies sigma square greater than equal to k square sigma square can be taken common from these two terms. We can write k square sigma square into minus infinity to mu minus k sigma fx dx plus this integral. Okay, that implies sigma square greater than equal to k square sigma square. What is this value? Minus infinity to mu minus k sigma fx dx. This value is nothing but the probability for x less than equal to mu minus k sigma. As I discussed here, that if we want to find out the probability x less than 3, that means I have to consider, suppose a random variable having the values 1 2 3 4 5, and we need to find out the probability of x less than 3. That means we have to consider probability at x equal to 1 plus probability at x equal to, so from 1 to 2, if continuous we are going to consider, then 1 to 2 fx dx. So same thing, it is written that fx dx, and the limit 1 to 2, here the limit is minus infinity to mu minus k sigma. That means this is the probability is belongs to x less than that of the 3, right? So this will be probability of x less than that of the upper limit, that is your mu minus k sigma, plus this is your mu plus k sigma to infinity fx dx, nothing but probability of x greater than equal to mu plus k sigma, right? So here you can see sigma square got cancelled, and we found 1 greater than equal to k square. What is this value? Probability of x less than equal to mu minus k sigma plus probability of x greater than equal to mu plus k sigma. This is nothing but this one. See, x less than mu minus k sigma, x greater than mu plus k sigma. So if we want to find out the probability of this range and this range, in general we can write probability of x minus mu mod this one. Okay, x minus mu mod greater than equal to k sigma, greater than equal to k sigma. So k square taken this side, that implies 1 by k square greater than equal to probability of x minus mu mod greater than equal to k sigma, right? That implies probability x minus mu mod greater than equal to k sigma less than that of 1 minus k square. Just I have written this one first and this one second. So k 1 minus k square, sorry, 1 by k square is greater than that of this one, or this one is the less than that of the 1 by k square, which is proved. Our first statement is proved. Now we are going to be prove this one. Okay, now from the equation number 3, one can be perceived one thing, that the maximum value of this one will be 1 by k square, because if this is less than equal to 1 by k square, that means the maximum value of this one is 1 by k square, right? And here in general all the ranges, two ranges has been represented. You can see that x minus mu mod less than k sigma is nothing but this range, and beyond this point, whatever the range or the values of x is represented as x minus mu greater than equal to k sigma, right? Now from this figure one can be easily noticed one thing, that here you can see this range and this range are mutually exclusive. The two range are not overlapped. This range, that means the values of x beyond this and beyond this are fully separate than this range. So both are mutually exclusive. So hence probability of this range and probability of this range will be equal to 1, right? Therefore we can write probability of this range, that means this one, this side and this side, all the values of x, and the probability of this outside range, you can say outside range plus inner range, probability of x minus mu less than k sigma, inner range will be equal to 1, because these two limit ranges are mutually exclusive, right? So that implies this range will be equal to 1 minus this range. So probability of this one, x minus mu less than k sigma, equal to 1 minus probability of x minus mu greater than equal to k sigma, right? So that implies we can write this one, probability of this one is greater than equal to 1 minus 1 by k square. Why? Because 1 by k square is the maximum value of this one, probability of x minus mu mod greater than equal to k sigma. How it is? You just watch. I'm explaining with one example. See here, 1 is belongs to 100% probability. Let 1 is belongs to 100% probability. Now consider 1 by k square, which is the maximum probability for this one. Let that maximum probability is your 60, right? Now 100 minus 60, if I am going to be calculate, then it will be 40. Okay, so 1 minus 1 by k square will be 40 if 1 by k square, which is the maximum value, taken as 60. Now consider another value of 1 by k square, which is less than that of this value, 50. Now subtract 100 minus 50, we can get 50. Now consider another value of 1 by k square. This is the value of 1 by k square. Okay, these are the values. Now consider another value of 1 by k square, which is less than that of the 60, and if I am going to subtract 100 minus 40, I am going to get 60. So here you can see that whenever we are going to consider the maximum value of 1 by k square, I got the minimum value of this one. Okay, because considering the other lesser value of 1 by k square, this value is increases. So minimum value of this one, with this example we found 40 when 1 by k square is 60. So hence probability of x minus mu mod less than k sigma will be greater than equal to 1 minus 1 by k square. Hence it is proved. Okay, this is your second one, this one, which is proved here. Okay, so this one also you can understand in this way. Another easy method is there, that consider equation number 3. This is our equation number 3. Okay, you just write down up to this much, and then you can write these steps instead these two steps. Okay, how it is? See, up to this much you written, up to this much, then you have to consider equation number 3. Equation number 3 is your this one, and just multiply minus and minus both the side. If this will be minus, probability of this one, this is less than equal to 1 by k square. If it will be minus and minus, obviously this sign will be altered. That means greater than equal to minus 1 by k square. Then I am going to add 1 this side, 1 this side. So 1 minus this one greater than equal to 1 minus 1 by k square. And here 1 minus this value is nothing but this one. 1 minus this value is nothing but this one. So hence this value is greater than that of 1 minus 1 by k square, hence proved. So what you have to do, either way you can understand and represent in your exam, no problem. But note in both the way, you just keep in your mind, and which one will be the easier, you can practice and remember. So up to this much you have to write down, and here we can write that this is greater than that of this one, because this is your maximum value by one step, or you have to write down these 2 to 3 steps to prove this one. Okay, so now same thing whatever we have been consider the steps for prove this Chebyshev inequality by considering x is a continuous random variable. You can consider the same procedure and consider the x is a discrete random variable. Also, you are going to get the same answer. So here in note I written that some same can be proved by using same procedure considering x is a discrete random variable. For discrete random variable, what you have to do, that instead of summation you have to write down the, sorry, instead of integration here you have to write down the summations. Okay, same procedure you have to follow and you are going to get the answer. But in the exam, either way you have to represent. Okay, you write down this one in your note and I suggest that you have to represent in this way. Another form of Chebyshev inequality which will be required for various numericals. So according to Chebyshev inequalities, we found this equal to this equal to this, and if we are going to consider k sigma equal to k into sigma equal to c, which is greater than 0 because k is positive integer and sigma is standard deviation, which is the root over of the variance, which is also a positive integer. So obviously c will be greater than that of 0. So now we have to put instead of k c by sigma. So this will be probability x minus mu greater than equal to, instead of k sigma I have to write c less than equal to 1 by c square sigma square or sigma square by c square, that is nothing but variance of x by c square. So this value, this is mu is your mean. So probability x minus mean, no, greater than equal to c will be always less than equal to sigma square by c square or variance of x by c square. And if I am going to write this one, it will be probability x minus mu less than c greater than equal to 1 minus 1 by k square will be sigma square by c square. So thank you so much for watching this video. I am going to give the link in the description from where you can download this note for your exam point of view. In your exam, you have to write down this one, and these two figures no need to write for your in your exam, but keep this explanation of range of this one and this one in your note. This figure you have to write down in your exam. Okay, because this, from this figure we can found this one. Okay, so only for that, only this figure you have to draw in your exam, but in your note you have to write down all the things. So this page and this page and this one with continuity I will give the note, and this explanation of range note I will give a separate page. Okay, so thank you so much for watching this video. Next class we are going to discuss this kinds of problem. Okay, thank you.